Hello, everybody. Jim Mandelbaum here with Gigamon, and today I'm joined by Jeremy Haltom with Ordr, and we're here to talk about how Order and Gigamon work better together, provide your network and device visibility. Jeremy, welcome.
Thank you. Appreciate the opportunity to speak today. So today we're going to be talking about kind of IoT, right? So looking at network and device visibility and what it looks like from a network view of things that we can do. So by 2025, just kind of setting the stage, we're looking at approximately 75 billion IoT devices. Now, that's quite a few devices. That's a very high growth rate. In fact, by 2025, we're expected to have on the entire planet somewhere less than 10 billion. So that's a lot of devices per person when we look at it from an overall perspective. So when we have this many devices, what are some of the challenges that we have? Well, it really comes around IoT security because there's billions of devices we just talked about. Every one of them has from a different manufacturer, different protocols. They're hard to patch, right? These are things that are designed to be plugged in, maybe put on a ceiling, put on a wall, and never touched again. They're things that security agents can't be installed on. Right? So we're not putting firewalls on them. We're not putting virus scanners, those sorts of things. Typically, they're built by a company who's doing something like a heating and air or some other kind of functionality and not really an expert at network security. So the security components are not built in. And they're designed for, to be in service for years and years. I mean, how often do you change your HVAC controller on your wall? How often do you change the IP cameras in your environment, right? These are the sorts of things that we have to deal with when we're looking at this explosion of devices that are out there. So we're talking about these things, right? The Internet of Things. Now here are some examples of things that are vulnerable to cyber attacks that we have actually found. So we found like a gate controller at a parking lot was sporting malware, right? It was one of the little arms that go up and down, and it was doing some very malicious things on it. Lots of WannaCry infestations, right? This particular was a manufacturing plant, and it was actually a meat processing plant, and one of the machines that was part of the entire process of this entire factory was infected. And this is something that we couldn't just turn the machine off, right? Because we can't shut down this entire multi-million dollar system. So we got to figure out some way of protecting it. Lots of old OSs. Right, especially when you're talking about. Oh, go ahead.
Yeah, I was going to say, I love this one because I run into a lot of clients that say we don't have obsolete operating systems, and all you got to do is walk down the hallway into the break room and take a look at that soda machine. And people don't realize that vending machines have operating systems, typically old embedded Windows XP or ME environments, and people don't recognize how vulnerable they are due to soda machines.
Absolutely. And that soda machine is actually a great example. I was in a healthcare facility here recently, and we were doing a discovery of everything on the network using the Ordr system. And it turns out there actually was a soda machine that was connected to the network on the exact same subnet as some of the medical devices. So these are things that absolutely happen, not just from the network location, but this older operating system. And when you're in certain environments where you have a factory that only gets upgraded, once every 10 years, or you have something like an MRI that gets, upgraded every 10 years, you're going to have old operating systems. We also have other kinds of devices. So smart TVs turned into listening devices, right? Every TV runs Android or some other OS now. And then you've got a lot of these devices that, even if they do have a little bit of security on them, they're sent out from the factory with really poor passwords or no passwords, and people forget to go change them. Right, so we had that attack a couple of years ago on a certain brand of camera, and they were able to turn all those cameras into botnets. All right, so all these sorts of things we can happen.
Or worse yet, you see the bad guys talking to the children in their bedrooms. That's even worse.
Yeah, that's 100% unacceptable. So how do we solve this problem? Well, Ordr solves it by watching everything on the network, so every piece of traffic, and we do all the discovery and everything else. But the question becomes, how do I get this traffic to the Ordr sensor, right? I don't do anything. I do I perform no value unless I get a copy of those packets. And using the Gigamon system with all that complete traffic visibility across everything, physical, virtual, cloud, you name it, including encrypted, I now have the ability to go do my job. So that's why we have this better together concept. So what does it look like in a normal environment? So a normal environment here is, this is a very common slide in the Gigamon world, but it's leveraging that infrastructure that you have, that full fidelity, to get all that information over to me. That way I have immediate ROI. I'm not having to worry about span ports. I'm not having to worry about, okay, where all the spans go, where am I going to put it on certain switches. All that complication is eliminated. And I get all the increased security, right? So as soon as I get all this information to order, I'm providing that IoT, OT, IOMT, that's the medical devices, all this risk I'm reducing across the network. And I'm pulling it all back into a centralized resource, right? Into your NetOps, SecOps, and your line of business teams, right? In the case of line of business, one of those might be the biomed team in certain organizations. And because Gigamon has that complete device visibility on in, out, encrypted, all that sort of stuff, I can now have 100% visibility that I would never have before. So what are some of the integration opportunities? Or actually, let's back up a second. So let's take the 3 key pillars of what the order system does. So the first one is the discovers. So once all those packets are being sent to me, I can discover what's going on. I do that agentlessly, so there's no agents on anything, it's completely passive. Then I'm classifying things by make, by model, by serial, by operating system. Because I'm getting all these packets, I can now do DPI. I can dig way down in the packets to start getting lots of rich contextual information about what I have out there. Now, once I know about everything, the next thing that I do is I profile them. So what are those devices doing? Right? Analyzing their communication patterns, understanding if there's any kind of IDS type of events that I need to worry about. So anomalous packets. Because I have some deep information about OS and those sorts of things, I can start looking at external systems and figuring out, is there a CVE or ICSA or ICMA or all those sorts of things. And then the third thing is okay, now that I know what they're doing and how they're supposed to be doing it, how can I automate things like micro-segmentation, zero trust, by enforcing those policies at whatever the policy enforcement point is. So the way this kind of works is we have our sensor. So the raw packet comes in from the Gigamon over there on the left-hand side. The sensor or sensors, if it's a really large environment, will take that data, combine it down into what we call metadata, and dump that into the Order data lake. So the Order data lake is inside of our SCE, or our analytics engine. And that does the DPI, extracts the metadata, application decoding, a lot of these sorts of things. But it also can ingest other forms of data as well. So things like Windows AD information. So I can actually join the domain or do WMI and pull in Windows level information all the way down into, do you have a BIOS password set? I can also look at NMS information. I can look at IPAM, so like at info blocks or something like that. I can also look at logs and traps from certain things like firewalls. So again, pulling in tons of information so that we can build that profile of what these things are supposed to be doing or what they're doing and versus what they're supposed to be doing. And then 3, automatically through automation, enforcing those policies out into the network.
So let me ask you a question about this data lake, and I know you're going to go into it a little bit, but we have clients that are in different regions. So we may have clients in North America, we might have clients in EMEA, down in APAC, and the concerns around where is the data stored. So can you kind of talk to that point about where this data lake can live and does live?
Sure. So the raw packets are obviously going to hit these sensors. Those sensors can absolutely be distributed out in the environment, so we're not having to home run everything necessarily. We'll talk a little bit later about some of the cool things we can do with Gigamon to maybe truncate some of that and shrink it, even if we are using a centralized sensor architecture. But the data lake can live in 2 places. One, it can live in our cloud. So we have a SaaS service that you can run. Or for folks that don't want their data coming off of their premise, we have an on-prem solution as well. So it's very easy to work in both types of environments. It's really interesting. You know, some of the largest customers that we have with hundreds of thousands of devices that we've discovered, in fact, closer to millions of devices or 1 million devices. You know, some of them are on-prem and some are in the SaaS system. So it just totally depends on the internal architecture.
So for those that are concerned about compliance issues around where the data is stored, say, it's got to stay within region, within geographically or within country, deploying in their own environment is absolutely feasible. So you don't need to worry about the compliance initiatives around with dealing with Ordr to do this.
Yeah. So things like GDPR, obviously your data needs to stay in Europe or in Canada, depending on where you are. So all those sorts of things, if it's a concern, bring it in-house, you get to fully control that information. For folks that happen to be in the healthcare environment, one of the things we don't store in our data lake is anything that's PHI related. So we always drop PHI information instantly, so we don't want to be in that particular world, because that's just another thing you have to worry about from a compliance standpoint with HIPAA and those sorts of things. All right, so as I mentioned earlier, all that stuff comes in through the data lake, threat feeds, but one of the other things I didn't mention was the CMDB asset information. So one of the things when you're talking about discovery, so the first of the 3 pillars that I mentioned earlier, there's usually a lot of workflow around that as well. Things like if I'm a big company, when I buy a new printer or something like that, it comes into the warehouse and somebody puts it into an asset database, puts a sticker on top of it with maybe a barcode or something like that, and sends it off on its way. Well, the problem with that is twofold. One is from the network, I can't learn about the barcode. So having a asset integration is really important. But the other part is that asset inventory database is usually static. If it's not learning about what's on the network and say, hey, by the way, that thing updated its firmware version. Oh, by the way, somebody moved it from location to location. That database quickly goes out of sync. So I can provide lots of real-time information to other systems as well, even in that kind of basic initial discovery flow. So what are some of the other things that we get when we add Gigamon to the traffic that's sent to the Ordr sensor or sensors? Well, first off is deduplication. A lot of times when I'm going in and I'm just getting span traffic, and this happens quite often, people will do something like show all ports RX and TX and put it into a span. Well, all of a sudden I'm getting duplicate packets because it's RX and TX on every single port, right? I need TX on the inbound, I need RX on the other one, and I actually don't have to have every traffic. I get everything that way. So by running it into a Gigamon, immediately reduces the sensor workload significantly, right? Also, packet and flow slicing. So I talked about DPI earlier. Well, there's a lot of things when I'm doing DPI. I only need to look certain depth into the packet. And so you can take the rest of that, cut it out. And again, when it comes into my sensor, one is less traffic getting to my sensor. And two, when it gets to my sensor, it's less things that I have to process. So there's a lot of things from an optimization standpoint that makes sense.
Yeah, and when you start thinking about larger facilities where you have remote buildings or multiple buildings, and you have a need to want to send it off to either central locations or however you're going to flow the data, the idea that you don't need the entire packets to do it really does reduce the amount of load on the network itself. So you get a lot of benefits on it from a network perspective as well as the load on the sensor.
Absolutely. And I didn't talk about it, but here on the left-hand side, you see that there's one packet coming in from the bottom and it's going out to your web security, your IDS, your SIEM, and also over to the Ordr system. Again, allow one packet to come in, let Gigamon route that packet appropriately, and then distribute it to the end devices as necessary. Otherwise, each one of those will have their own individual stream, which again makes no sense.
Yep, that whole Gigamon, see it once, use it many theory.
Exactly. Also, this is a huge one. So looking at Netflow and metadata, I can do as well. So there's a lot of things that come into the Gigamon that can be sent over to me. But the number one key thing I see on this particular slide is the decryption. If something's encrypted and it comes to my particular sensor, If I'm not decrypting it, which for me to decrypt it, I actually need to have the backend keys, which is typically not the case. I need something in the flow that will unencrypt it and send all that packet to me so I can do the work that I need to do. So super, super critical, very important piece of the pie right here.
Yeah, what's really great, can you go back that slide real quick? I'd like to kind of address that SSL thing. One of the things that's really great is while we do a great job around decryption of SSL in taking that traffic and that flow and sending it to you, there also are some proprietary encryption algorithms. Do you want to talk about how you guys deal with those?
Well, so there are a couple of devices, I wouldn't say necessarily proprietary per se, but there are
yeah. Okay. Go ahead.
I would say there are a couple of devices where I can load the key into my device, into my sensor, and decrypt. They're primarily with very specific, very dedicated pieces of equipment that are very expensive. But when it comes to everything else, just general encryption or anything else, if I don't have it decrypted before it gets to me, I can't understand anything about it except for the standard 5-tuple, right? Source, destination, port, etc. All right, so what do these sensors look like? So you're thinking, well, okay, I want to put some of these sensors in my environment. Well, we got a couple of different ones. The sizing is not quite right. That S100 there on the bottom right is actually only slightly larger than an Apple TV. That's used upwards of, smaller locations like 500 endpoints. The S500 is more like a little tiny desktop computer, one of those little super micro desktops that is usually around 2,500 endpoints. And then we move up into our 1U servers, your typical 1U box that goes into a rack. Those are for 10, 20,000 and up in devices. So we've got a range across the board. So let's talk a little bit about some of the use cases. So where should I actually tie this kind of technology into my network? Or what are some of the things that my CEOs come down to me in the IT department and says, I need you to do the following? Well, the first one is asset inventory. So what are all the devices in my network? What risks do they bring? Again, back to that old one, finding the devices with the old OSs, right? The HVAC server, the vending machine, those sorts of things. Compliance. So how do I ensure that medical devices aren't being compromised by other devices, that my credit card readers are not on the same as my guest network, right? How do I take a step back and apply some rules to my network based upon the compliance that I have as an organization? Whether it's PCI, HIPAA, whether it's financial compliance, there's so many different kinds of compliance out there these days. It's hard to keep track of who's supposed to be complying of who. Third is device utilization. So are my devices being utilized properly? Do I have too many printers, right? If I have tons of printers and they're not printing that often, so I can look at the flows and they're being used once a day, maybe I don't need to order more printers, all right? Or if I'm in a medical environment, do I need to worry about buying more infusion pumps or patient monitors? Threat detection. How do I find devices with vulnerabilities like Ripple 20? There's a 2 or 0 missing there, but it's actually supposed to be Ripple 20 or Urgent 11 or all these sorts of things, particularly in the IoT world or the headless devices world, where they're using a lot of the common IP stacks. So like Ripple 20 is everything that uses the Trek IP stack or certain versions of the Trek IP stack. Where are those devices? Is there anything with ransomware? Going down to NAC augmentation, right? If you are doing any kind of Cisco ICE project or Aruba ClearPass or some of the other NAC vendors that are out there, one of the toughest things with NAC is knowing what's actually out there, right? Especially for headless devices, because they don't support 802.1x with a supplicant, right? So you have to do MAB or some of those sorts of things. And then if you hear, a lot of this zero trust segmentation, so people moving to all right, let's lock all the ports down and do a zero trust until we know who you are, then we'll allow you on. So how do I do that if I don't have a tool that figures out what things are, right? And that's where we come into play. So kind of drilling into each one of those a slight bit more. So the asset inventory. So here's a screen of our system. So this is all the different devices we found. You can see the nice little pretty pictures, right? If we know about it, And we've seen it before, the pictures are there. So phones, all sorts of different kinds of devices. And I talked earlier about integrating this with CMDBs or CMMS systems, depending on what industry you're in. So now I'm building a workflow with other systems in my environment to figure out what's going on. And we start answering questions like, how many Amazon devices are on the network? How many servers do I have? I can even look at the servers and go, which ones are running virus scanning and which ones are not, by just watching which ones talk to AV servers, right? Think of the rich data you can get by just knowing how things are communicating, what they are and how they're communicating on the network. And then how many old operating systems do I have? The old Windows XP stuff that seems like no matter where I go, there's one in every environment. It's crazy. Next one is that threat detection. So now I know everything on the network. I've identified it, I've classified it, I've profiled it, all the good sort of stuff. Now I need to start looking for anomalous behaviors. So let's say you have in your infrastructure, your network, say 100 different kinds of IoT devices, from HVAC controllers to maybe some security cameras, to the door locks, to the access control systems, all the way out to the gate at the front entrance to the HQ building. Well, if you had to go in and do sniffer traces and try to figure out how all these things are supposed to be communicating and compare each device to similar devices and figure all that out on your own, you'd be there for days and days and days. So what we do is by our grouping of devices and the profiling, I can take all of the devices, so this particular case, a C3PO device, and I'm comparing it against all the other C3PO devices, and I can start figuring out what's normal behavior and what's not normal behavior. So using some ML-driven baselining, I can say, okay, you have 100 of these devices, 99 talk like X, one talks like X, but it also has Y communication flow. I'll highlight Y and alert you to it. So I'm building real-time flow analytics. I'm baselining by device type, looking for those anomalies and alerting you that, hey, this thing's talking funny, you need to go take a look. So really easy to do this across all the devices in your network without having to go spend all the time and effort of doing it by hand. And we take that information and put it into our risk dashboard. All right, so all CISOs, all security people want to know is, what is my risk score, right? Am I more risky than I was yesterday, or is my risk going down? All right, because we all want to go down in the risk. We want to get safer and safer. So looking at all the different kinds of things that we do, from external communications, identifying those vulnerabilities that I talked about earlier, looking for threats, so different kinds of communications, expired certificates, all this stuff comes in here. We have a nice dashboard, and right at the bottom, you can actually see the trend from how many critical devices I have, high risk, medium, low, and normal. So obviously we want the normal to trend up, and we want all the other ones to trend down. One of the other things we can do is some compliance. So looking at some of the compliance stuff we talked about, some compliance is really looking at CVEs and ICMAs or FDA recalls or those sorts of things. But we can also start visualizing certain things as well. So in this particular case here, this is our patented constellation view. So the outside ring has all of the external communications, so internet, if you will. The middle ring is the types of devices I have in my network. And then the inner ring is my local network services that we've discovered. So in this particular case, we've clicked on the facility devices, and you kind of see on the right-hand side of the screen, it's showing you the different kinds of devices, some HVACs, UPSs, those sorts of things. And we can start looking at what VLANs they're associated with. So are they in the right location, the wrong location? And I can, it's not shown here on this particular map, but I can click on any one of those lines, and it'll actually show me for all my facility devices what they're talking to, in this case, bad URLs, non-US. So using web reputation scoring, we can show you, hey, you got facility devices, which generally shouldn't be talking to the internet at all. If they do, it's a very small number of locations. And in this case, not only is it talking external, it's talking to bad URLs. So very quickly, we can visualize all this communication to make sure that things are talking appropriately.
So one of the things I like about this screen, when I got a chance to actually play around with the screen, was it kind of showed me devices that normally should be other, and that was that weird link that showed it was speaking to something else, you want to go and investigate. So I think what's great about this is that it gives you the ability to see what stuff that you do expect, as well as the stuff that you don't expect. So it gives you that comfort confirmation, yep, all is well, but also the ability to say, that doesn't look right. And it may be fine, but at least it gives you the ability to go research it.
Absolutely. It's a great comment. And one of the ways that I actually use this in my customer networks is you see in the upper left-hand corner, there's one called Public Network Services. So that's things like Google's DNS. It's like pool.ntp.org. A lot of the common kind of shared network services out on the internet. And a lot of people have policies or rules internally that say, I want all my DNS queries to go to my internal DNS server, right? Because I have security, some DNS security and other things set up. Or I want everything internally to go to my own NTP server, right? That way not everything's talking out on my internet link to go get NTP, right? Just from a utilization standpoint. So I can actually click on that and see what all the different devices are using to, or what devices my network using 8.8.8.8 for DNS, which ones are using pool.ntp.org. So even if I'm not looking at it from I just want to verify configurations, I can start looking at, people are not following the policies I've set up. Let's go adjust those. All right, so we've talked about the discovery. We've talked about kind of the risk and the profiling of the devices. That third kind of step in the stool, or a leg in the stool, is, okay, taking all this information and how do I use it for segmentation? Well, let's talk about what segmentation really means. So unsegmented means unregulated behavior. So it's taking, in this case, a zoo example. We're taking all the animals, we throw them into the zoo, so the zoo being the network, and all of the animals, no matter if they're herbivores, carnivores, whatever, are all mixed together. Well, think about what happens.
It'll be a lot smaller zoo by the end of the day.
Exactly. It's not a good thing. So segmentation means getting all the animals into the right cage. Or when we're taking it to our network, it's taking all of the like devices and moving them into either the right VLANs, maybe the right subnets, maybe even all the way down to ACLs at the switch port, right? So something that's endangered, like the polar bear here, or something that's very critical, high risk in your environment, you're actually creating ACLs all the way down to the switch port to restrict what it can see and do, which also means nobody else can get to it and hack it as well. Or it might be more like the herbivores, which might be, just all your printers and your workstations all kind of mixed together because they're all friendly with each other. So it really just depends on what you're trying to do. And even over in the left-hand side, we got the quarantine, right? So we got a new animal coming in. Maybe we have a new device we've never seen before, and we want to do a little quarantine on it. So it really makes sense by having a system that can identify everything, classify it, figure out what's normal, and because I've classified it, being able to start creating policies for the different kinds of devices you have. Now there's kind of two levels of segmentation. There's the bottom up. So you're doing that for control, right? Looking at that, like I said, the polar bear that's endangered. So saying for this one device, this is all it can do. Or you can do a top-down segmentation for scale and say, okay, all workstations get X, or all devices of this profile get Y, right? So it just kind of depends on which way you're going. The Ordr system is very flexible and allows both. And the way it does is we use our zero trust segmentation with that Ordr policy generator. So when we looked earlier at that screen that had some of the flow data on it, well, when we're determining what and how a device is supposed to be communicating with it, we build a baseline. So I gave that example of the 99 devices talk X, Y. That last one was talking X plus Y. Well, that X becomes the baseline. So what is the normal behavior? We translate that into an allow and deny kind of setup, right? So it creates an ACL or a DACL or whatever. DAG just depends on the type of enforcement point you're talking about. And the Ordr system will automatically translate the allows and denies into any one of these enforcement modes that you see here, whether it's all the way down at a switch port, so the access switch there at the bottom of the list, working up to distribution, wireless controllers, core, looking at things like your NAC tools, like a Cisco ICE or CPPM from ClearPass or Aruba, all the way up into maybe you're just doing it at the edge with firewalls, or maybe it's something in this data center with VMware, so using NSX. So anywhere where some tool that provides enforcement needs those rules generated, the Ordr system can build those rules based upon the fact that it knows what the normal and correct behavior for a device is. So very, very powerful when you get into that zero trust or the micro-segmentation policies. So as part of all of this, I talked a little bit about the CMDB and the CMMS integration. So you can see there's some CMDB and CMMSs in the upper right-hand corner, but that's actually just a small portion of the integrations. The Ordr system becomes smarter and smarter the more data you give it, whether it's through infrastructure setup, whether it's through SIMs, whether it's through some NAC devices, through vulnerability management systems. So think about something like Rapid7 or Tenable, right? These are devices that do active scans on your network. A lot of times you do active scans against IoT or some of those more, basic kinds of devices. If you do a heavy duty scan, what happens? They fall over, right? That's not good in a normal environment because you may kick off your HVAC controller and everybody gets a little irritated when it gets warm in the office. But if you're in certain environments where that might be a critical control point for a valve in a factory, or it's a patient monitor connected to a patient in the hospital, by being able to know everything on the network and feed that intelligence into these other systems, this is where Ordr makes not only ourselves smarter by connecting with everything else, but we make everything else smarter at the exact same time. All right, so do we have any questions or answers for today?
Great. If anybody has any questions, feel free to type it in and we'll answer that for you.